Hey guys, hoping all is well with everyone. So in today's question, we're going to be looking at a question that really does a good job of mixing geometric principles along with algebraic techniques and equations, but it unfortunately has a very good way of being very deceitful to a lot of students. And what I mean by that is it has a way of making itself look a lot easier than it really is. One student or another will look at this and think that they have to follow this certain pathway, which isn't necessarily incorrect, but they don't realize that there's another component to it that leads to a more complex part of the problem. So it has a very good way of kind of hiding how daunting it can really be. So we're going to break this question down step by step. If you guys want to take the opportunity to go ahead and pause the video right now to give it a shot and then come back, we'll go ahead and jump into it. So if you guys are looking at this question and you're kind of reading through it, you're kind of getting the idea of where the geometric part of it really just kind of jumps at you. So the question states that a design team is creating blueprints for a new ramp at a skateboard park. The ramp will have the shape of a right triangle with a hypotenuse measuring 13 feet. One of the shorter side's legs is 7 feet longer than the other. What are the lengths of the two shorter sides? So one of the biggest things that I would recommend with this problem right off the bat is to draw a picture of what you're looking at. So if we go ahead and draw our right triangle here, we have that its hypotenuse is 13 feet, and that gives us a lot of information right off the bat. So it kind of gives us a clear image of what we're looking at, but it also is going to, in a moment, exactly show what we're trying to solve. So if we keep going forward with reading the question, so we have the fact that the ramp will have the shape of a right triangle. I'm going to go ahead and highlight that, with a hypotenuse measuring 13 feet. Now, I've kind of talked about this in previous videos, but sometimes reading the question more than once will help you kind of get a better understanding of what's mathematically important and what is what I call fluff. It's there just to kind of set up the scenario of the problem. It's not mathematically important or irrelevant. And then the next sentence says, one of the shorter legs is 7 feet longer than the other. So this whole sentence is pretty much important because it tells you the relationship that one side has to another. Now, one thing you want to definitely be careful about is the fact that these shorter sides are relationship to each other. They don't have a relationship in terms of the 7 feet longer expression in terms of the hypotenuse. So that's one simple mistake that students can make. So the first thing that we want to do is go ahead and establish our variables. I'm going to be kind of plain here and just use x, but the two variables, or what we really need to do, is establish algebraic expressions that relate the two sides together with the information verbally stated to us in the question. So I'm going to just say this is shorter leg, longer leg. And this is where you can be a little flexible. So remember, the moral of the story is we're going to be using the Pythagorean Theorem here, and that the sides that we're going to be kind of pivoting is going to be a and b. And so a squared plus b squared equals c squared. So remember that your a and b side lengths, they can be mathematically related to each other, but you can interchange them. But for the intents and purposes of this question, I'm going to go ahead and let the shorter leg be x and the longer leg be x plus 7. And that just mathematically makes sense. The longer leg should be 7 units longer than the shorter leg. Okay. Now what we're going to go ahead and do is we're going to go ahead and kind of implement those into the picture. So we have that this is x plus 7. So I'm going to go ahead and call that step 1, just for defining kind of step-by-step breakdown. So step 1 is to define variables. Okay. So step 2 here, what we're going to do is just to simply write out the Pythagorean Theorem equation, okay? So we'll go ahead and do that. We have a squared plus b squared equals c squared. And then just remember from terminology and just principles of the Pythagorean theorem, it just states that the sum of the squares of the two shorter legs or sides of a right triangle are equal to the square of its hypotenuse. Okay, so step 3, what we're going to do is we're going to go ahead and do a direct substitution of what our particular A and B side lengths are. Now, this can get a little daunting for students because they're algebraically represented, but that's okay. They're still going to be put into the equation as normal. We're just going to have to do a little bit of simplifying in the process. So it's all good. So step 3, direct substitution of algebraic expressions for particular scenario. There we go. Okay, so let's go ahead and make that substitution here. So we're going to go ahead and let A represent x, and we're going to square that. And then B is going to be representative by the expression x plus 7. So we have to expand the entire expression, or we have to square the entire expression. So you guys are going to look at this, and if you're looking forward, you're going to notice that we're going to be using the FOIL method. And then because we also know the value of c, we're going to go ahead and make that substitution as well. Okay. Oops. So I'm going to go ahead and simplify this here. So we have x squared. And then what we're going to do is we're going to use the FOIL method. I'm going to kind of do it over here to expand that second expression that is squared. So remember that if you have a binomial that is squared in the way that it is, you can change its present form and just multiply it by itself to allow you to see the FOIL acronym more in action. So remember, FOIL is an acronym for the 4-step multiplicative approach to expanding two binomials, or in this case that we see. So we have first being the letter f, that's going to be the first terms of the expressions. So that's going to be x times x, which is x squared. And then we have O, which is outer, which is going to be x times 7, which is 7x. And then we have the inner term for I, which is going to be the two innermost terms of the expressions multiplied side by side. That's going to give us another 7x. And then we have L for last, which is just going to be the two last parts of the binomial, or latter parts of the binomial. So the 7 times 7, that's going to be 49. Oops. So now we can go ahead and put that into our equation here. And then on the right side, 13 squared is just going to be 169. So as you guys can see, as we're going forward with this, you guys are seeing those x squared terms, which is going to lead us to some type of quadratic equation. So if we go ahead and simplify one more time, we're going to get Combining our like terms, so x squared and x squared is going to give us 2x squared plus 14x is its own term that doesn't have any other combinable terms, so it's just going to stay as 14x, and then plus 49 equals 169. So what we've originally started with being a Pythagorean theorem problem now becomes a quadratic equation problem. So now what we're going to do is we're going to solve this quadratic equation, and I'm going to approach it using the quadratic formula. I know that the quadratic formula can be daunting, but in this particular sense, it can be really helpful. One of the things that I'm going to do before we kind of simplify it is I'm going to set it to 0 because that's the first thing that we need to do. But then I'm going to take another further step and I'm going to factor out something to make it a little easier. First, I'm just going to go ahead and erase this really quick just to give us some room. Okay. Okay. So let's go ahead and progress forward. So the first thing that I need to do to solve a quadratic equation is I need to get it equal to 0. So the way that I'm going to do this is I'm going to subtract 169 from both sides. Now remember, solving equations is kind of like a balance scale, right? So because I want to keep the weights distributed equally on both sides, which means mathematically I don't want to change the value of either side, I'm going to apply operations to both sides simultaneously. So this is going to give us 2x squared plus 14x minus 120, so just be careful with your subtraction there, you're going to get some negatives, but that's okay, equals 0. Okay, so I'm going to go ahead and bring this up here. So we have 2x squared plus 14x minus 120 equals 0. Now, to make our lives a little bit easier, I'm going to also go ahead and factor out a greatest common factor. So the value here that's going to be the greatest common factor is going to be 2. So I'm going to go ahead and factor out a 2. Remember that factoring is kind of like reverse division, so, or the opposite of multiplication, so to speak. So whatever factor that I take out of each of these terms, I have to also represent what remains. So if I take a 2 out of 2x squared, I'm left with x squared. If I take a factor out of 2 from 14x, I'm left with 7x. If I take a factor of 2 from minus 120, I'm going to get minus 60. Okay, let that equal 0. Now what I'm going to do is, to make things a little bit simpler, is I'm going to divide both sides by 2 so we can go ahead and get rid of that factor of 2. So all that we have now is that x squared plus 7x minus 60 is equal to 0. Now, there are a couple ways you can approach this. Like I said, I'm going to be using the quadratic formula, but you can factor it with, in my days it was called the a times c summa b method, where basically you're going to take factors of c times a, which are factors of negative 60 that add up to positive 7. Some people call this the arc method, I believe, but there's a little bit more kind of a different approach between the two specific techniques. But let's go ahead and jump into the quadratic formula here. I'm going to go ahead and kind of make a little bit more room here. Okay. So, remember our quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, let's go ahead back here for a second. Remember that if a term doesn't have a coefficient on it, it is inferred as 1. So the reason I say that is it's going to help us identify our a value here for our a, b, and c that we're going to plug in directly for this formula. Okay, so we have that our a is going to be equal to 1, b is equal to 7, and c is equal to negative 60. Alright, so let's go ahead and plug things in as we go. So the first step in your quadratic formula approach is always just going to be a direct substitution. I don't want to... this actually looks like a 1. Sorry, guys. Let's see if I can fix this. There we go. Okay, you always want to do a direct substitution so you can see what values are and how they're going to be evaluated. So we have negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 60 all over 2 times 1. And now what I do particularly in this next step is I'm going to break this into the two parts of the formula. In other words, the two fractions or the two solutions that you get. That's kind of what this plus and minus does. It kind of breaks up things into the two solutions that we're going to get. So we have negative 7 over 2 plus or minus, and then we're going to go ahead and evaluate this guy. This is going to be 49 minus 4 times 1 is 4 times negative 60 is negative 240. Okay, and that's all over 2 still. And then we have that this is going to simplify to, whoops, x equals negative 7 over 2 plus or minus square root. So be careful here with your double negatives. So when you subtract a negative, it's like adding a positive or adding the opposite. So 49 plus 240 is positive 289. And that's going to be over 2 as well. And then we're going to go ahead and simplify this further because 289 is actually a perfect square. So this actually is going to come out very nicely. So negative 7 halves plus or minus and then the square root of 289 is going to be 17. And that's going to be over 2. So now you have our two solutions. So we have that x is equal to negative 7 halves plus 17 over 2. And we have that that's going to be equal to, so since we have a common denominator already established, negative 7 plus 17 is 10 over 5. And we also have that x is going to be equal to negative 7 halves minus 17 over 2. So this is where, again, you want to be really careful with your subtraction because you're taking a negative and you're subtracting even more. So this is going to be negative 24 over 2, which is going to be giving us simplified fractions. 10 over 5 is, oh, oops, I'm sorry, I made a mistake here. My fault. This is 10 over 2. Sorry about that, guys. This is 5, and then this is negative 12. So now, this is where we're almost there, but this is also where one of the steps that can like trip you at the finish line, quote unquote, because you're given two answers, which makes you think that you have two sides that you're looking for, right? Unfortunately, we're solving for x here, so we're trying to figure out the value of x directly, which is going to allow us to solve for the one shorter leg, and then we can algebraically use the relationship that the longer leg has with the shorter leg to determine its value. Here's another thing that can throw people off. The fact that this is a ramp, a tangible object, means that it has a finite length and unit of measure to it. For basic physics and principles of just matter, we can't have a negative length of measure for an object. So from a mathematical standpoint, any values that x has that are negative are going to have to be null and void, because there's no way that this shorter leg of the ramp can be negative 12 feet long. So with that justification, we can cancel out that possibility, which means that x, or the shorter leg distance, is 5. So keep that in mind too, because that gives us information which is valid to what we're trying to solve, but we also have a little bit more work to do. So what x equals 5 means is that the shorter leg is 5 feet long. Okay. Now, to solve for the other leg, we can say that x plus 7 equals longer leg five. And then we can just go ahead and make that direct substitution to solve for the longer leg. Okay, so after all is said and done, our final answer is that the shorter leg is 5 feet long, the longer leg is 12 feet long. Okay, so as you guys can see, a lot of steps to take, especially ones that can cause some simple errors. So again, this is one that you really want to just get organized very quickly, but you also just kind of want to do it in a very step-by-step approach, just to make sure you're accounting for your signs, being careful with your direct substitution into not only your Pythagorean Theorem equation, but your quadratic equation, and just being really careful, and then also kind of just looking at the logistics and the legitimacy of your answers. For example, positive units of measure only, because negative units of measure aren't physically possible here in real world mechanics. Okay, but I hope this helps you guys out, and I hope you enjoyed the video. Again, if you like the content that you see along the channel, please don't hesitate to like and subscribe, and please don't hesitate to reach out with any questions or other requests that you may have. But I hope you guys are doing well, and again, thank you so much for watching, and as always, please take good care and be safe. Bye.